Hello guys, welcome back to another tutorial. Hit the bell icon button so that you don't miss out any tutorial.
Welcome back. Super excited. Moving forward in this short lecture, about 4 or 5 slides, I'm going to talk about the concept of features and labels within machine learning. First, let's take a look at what a feature is. So features, think of them are as independent variables, right? Variable is something that stores data that acts as the input in your system. So prediction models, when created, they use these features to make predictions. It can also be set as a property of your training data. So again, features are simply like an input, right? And then of course something gets processed and you do get an output at the end, which is the prediction. So let's talk about an example. For an intelligent agent, which learns to classify types of fish, features could be size, color, shape, scale, patterns. Similarly, a dog could have the color, hair, type, and so on. So a feature is one column of the data in your input set, right? So let's say you have a CSV file and you have separate columns, okay, or several columns within that CSV file or Excel file. So one of the columns you need to identify as your feature column because it's going to take that column and based on that column, it's going to go ahead and move forward within the machine learning processes. So for instance, if you're trying to predict, let's say, the type of pet someone will choose, your input features might include age, home region, family, income, etc. The label, on the other hand, is the final choice, such as the dog itself, fish, iguana, rock, etc. Right? So we have a feature and we also have labels. And once you've trained your model, you will give it sets of new input containing those features. It will return the predicted value or label, right? Which is the pet type for that particular person. Label, on the other hand, in machine learning, as I highlighted briefly earlier, is the output you get from your model, right, after training it, and that's called a label. So labels are the final output. And labels are also important, by the way, so that you know it's important to have labeling done within your machine learning data sets. And that sometimes could be time consuming because your data really is not labeled. Okay, so when you're collecting data from the organization, for instance, or from any other sources, it's really just data, right? Raw data. So it's not labeled. Okay, and that's really a challenge. Sometimes could be a challenge within the machine learning processes. But labels are again final output. For example, let's say you fed the above data set to some algorithm, let's say regression or any other k-means, and generates a model to predict gender as male or female. So in the above model, you simply pass the features such as age and height. So after computing it, it will return whether it's male or female, right? So you get the idea. Great. Here's a visual example that sets the record straight. So two pictures here. You see a parrot, that's a bird, right? And then that's the label, because it's a bird. Now features are feathers. Similarly, a cat is a label and features could be fur. So you can kind of identify now the difference between what a feature is in machine learning, right? And then what a label is. And that's important because as we move along, I'm going to be using these terminology and terms interchangeably quite a bit, even in the demos. I'm going to talk about data cleaning before you get into the machine learning solution. And this is one of the steps that by far is not only just challenging, but also most time consuming as well. So let's take a look at what are the elements that are involved in cleaning up your data. Before I talk about the actual data cleaning part, just a recap here so far. So from starting with the machine learning problem framing that we've already discussed as the first step. Right now we're in the step 2, which is developing and preparing our data sets. And we're talking about data cleaning, data integration, data collection, and so forth, right? So here in this lecture, just briefly, about 3 slides, I'm going to talk about the importance of data cleaning. And of course, from here, you'll notice that data augmentation leads directly to our business goal evaluation, okay? So what that means is your data plays an integral part and role within machine learning process. You don't have the data set up correctly, or if you don't have the correct data, you are not going to achieve your business goal. In other words, it's not going to answer your target answer, right, that you're looking for, or your target question that you posed in the first place. You need to have the relevant data before it can answer your question or do the prediction. Great. So here's the data cleaning. The main aim of data cleaning is to identify and remove errors, remove the duplication of data in order to create a reliable data set. It's one of those things that everyone does, but no one really talks about. In my experience, very few individuals actually make this a big deal within machine learning, because everyone is doing machine learning, right? But no one is talking about data itself. The cleaning of data itself is very, very important. And it's an essential part of machine learning. For the most machine learning projects, by the way, just so you know, I would think about 80% of the effort is spent on data cleaning, okay? Which means labeling your data, cleaning up your data, removing duplicate values, unwanted information, and so on. So that's a pretty manual process at this point in time. So proper data cleaning can make or break your project. So if you are a machine learning engineer or just getting into this field and you've been given a project to do, I would spend most of my time in making sure that I have the right data, cleaned up data, before I can create the machine learning algorithms. So it can definitely make or break your project. Therefore, professional data scientists usually spend a very large portion of their time on this step. Now, of course, we use tools like we use Python, we use other scripts, right, to clean up data to shorten the time, maybe some advanced tools, but typically still you need to make sure that your data is just right. Remove unwanted observations. The first step to clean up your data is obviously to remove any observations that are not desired and not wanted from the data set. This includes duplication or irrelevant observations within your data. By irrelevant observations, we mean that actually don't fit the specific problem that you're trying to solve. Let me give an example. Let's say if you're building a model for single family homes only, you wouldn't want observations for apartments in there, right? It doesn't make sense. It's irrelevant data. Another example would be that I gave earlier. If you were trying to predict employee retention rate within the organization, you will need the HR data, the employee information, right? And so forth. So it has to be relevant. Also need to remove the duplication of data, which is typically the observations most frequently arise during data collection, such as you can combine data sets from multiple places, you need to scrape data, receive data from client departments, and so on. So these are the two main elements you need to watch out for when you're working with either irrelevant observations or duplicate observations. And lastly, filter unwanted outliers. Outliers was one of the things, data values that do not fit within the chart, right? That's basically an extreme value. So outliers can cause problems with certain types of models. For example, in linear regression models are less robust to outliers than decision tree models, okay? In general, if you have a good reason to remove an outlier, it'll help your model's performance. However, outliers are innocent until proven guilty, so you should not remove an outlier just because it's a big number or it's just an outlier. So you need to make sure, kind of analyze what that outlier is before you decide to remove it. So that big number could be very informative for your model. So all of this information is important when you're trying to clean up your data. And again, most time is spent on this particular process. So I hope this helps. Moving forward, I'm going to talk about data splitting and shuffling in the next about 5 or 6 slides so that you're comfortable with the concept. And of course, I'm going to demonstrate all of this later on after this section is completed. So you will not only know the concepts, but also the hands-on application. So it's just going to reinforce all of these learning concepts. So right now, we're going to talk about data splitting and shuffling and why it's important in machine learning. What is data shuffling? So within the machine learning arena, we're often presented with a data set. So you have a bunch of data, you have raw data, you have data sitting in repositories across the enterprise, right? And then here you are with a question that needs to be answered through machine learning. So this data set that will be further split into training, testing, and validation. Typically, it's about training and testing, okay? But in my instance, I'm going to also talk about validation of data sets as well. And it's very, very important that data set is shuffled well to avoid any element of biasness or patterns in the split data sets. Because what happens is you take 100% of your data, and let's say you do a 70-30 split, okay? Now the split would mean that, or could mean that most of your data, the relevant data, could end up within the 70% of that split, or could end up within the 30% of the split. So that's going to cause a real challenge and issues later on. So it's important that data set is shuffled, okay? So it's like randomly shuffled to avoid biasness or formation of patterns within the split data set before training the actual machine learning model. Shuffling data simply improves the machine learning model quality and also improves the predictive performance. So these are again part of the data collection, integration, data management, because 80% of the time in machine learning, you would be preparing your data. How to shuffle? Let me give you an example, a very simple example so you have an idea. Let's say, starting from the left, you have the sample data set, which has two columns, ID and A. And you have about 4 rows, 1, 2, 3, and 4, with respective ages being shown in the sample data set. Now, the middle part is you add a new column and fill using random number generator. So here you are presented with the sample data set again, and in the middle part, you create a column, which is a random number generator. Subsequently, on the far right side, you'll notice that now you are going to sort the data set using that particular new column that was created, right? So this essentially shuffles the data. So once the data is now shuffled, then you can divide the data into training and test data sets. Okay, so straightforward but important. Data splitting. So once you've shuffled the data splitting is the act of simply partitioning available data into two portions, and typically usually for cross-validatory purposes. Okay, one portion of the data is used to develop a predictive model, and the other to evaluate the model's performance. So you have the training set and the test set. So it's about a 70-30 split, typically, or 60-40. Cross-validation. So the training or the test split does have its cautionary dangers. Okay, so you need to kind of be wary of certain dangers. And what those are simply, what if the split we make isn't random? Okay, once again, we've not shuffled properly, or if it's not random. Or the other question could be, what if one subset of our data has only people from certain state, employees with certain income level, but not other income levels, only women, or only people at certain age, right? So if you're only taking one part, it's not going to classify later on. It's not going to have that flag of 0 and 1, true and false, right? So it needs both data, the good data as well as the other data as well. So that's how machine learning is going to make that comparison, right? Especially if you're using a classifier. So this will result in either overfitting, even though we're trying to avoid it, and this is where cross-validation comes in. So you have the data set. If you look at the image here, you'll have the data set on top, you have the training, and then you cross-validate using the holdout method in testing, and then of course you do the data permitting with the training, validation, and testing. So just understand the concept of cross-validation. And then of course the test and train splitting of the data has its own danger that you need to be aware of. How do we cross-validate? one of the methods that we can use is called k-folds. So in k-folds cross-validation, you would simply split your data into, let's say, k different subsets, okay, or folds. And then you can use those k1 subsets to train that data and leave the last subset as test data. Once you've done that, then you can average the model against each of the folds and then finalize the model itself. Then test it again against the test set. So it's a process that you have to kind of go through, making sure that your data is cross-validated and it's prepared perfectly for your machine learning problem. Here's an example of how you would actually go about cross-validation. And this is, again, just an example to show you, okay? So it's not, you don't have to worry about all this code here. This is Python using the scikit-learn. So this program would allow you to cross-validate using k-folds. So if you're a programmer, you would understand this. If you're a non-programmer, not to worry. This is just to demonstrate how you would use Python, for instance, right? Just as an example, to do the cross-validation. So you run the program up above, the arrays that you see, and then the results are displayed in the picture below. So the function split the original data into different subsets of the same data. So in this lesson, just wanted to cover the importance of training sets, test sets, some of the dangers, and how to go about actually working with the cross-validation of data sets as well.
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.